Local presentation of the MacNeil Lehrer News Hour and Bay Area Newsmaker on KQED.
Tonight, shortly before midnight Eastern Time, the Voyager spacecraft will pass within 3,000 miles of the surface of Neptune. Viewers of many PBS stations, as well as CNN, will be able to watch along with scientists as the photos reach the Earth. We will discuss the Voyager mission in a moment, but first we have some background on the Voyager itself and the task it is undertaking some 3 billion miles from Earth. The impressive amount of scientific data and the visually stunning photographs sent back from Neptune are not due to state-of-the-art technology. In fact, Voyager 2 is a rather primitive spacecraft. Its cameras are 1960s technology, and the computer which directs the craft is less advanced than a child's Apple II computer. Yet the engineers and scientists at JPL have found ways to improve Voyager in flight.
Voyager is not the same spacecraft that we launched. We've altered it many times. It's been adaptable because of the way we can program its computers to cause the spacecraft to react differently to different things that we do. We've changed the way that it formats the data and sends it back to us. We've been able to send back compressed images so that we get back all the imaging data with far fewer total bits of information than we used to.
That's important because as Voyager gets farther away, it's able to send less data per second. At Jupiter, Voyager sent back over 100,000 data bits per second. Now it's down to little more than 20,000 bits per second. Engineers have also had to contend with the fact that Neptune is such a dim planet. Noon on Neptune is comparable to late twilight on Earth. To get good pictures, Voyager has been programmed to make slow, jiggle-free rotations to allow for long and smear-free exposures. In fact, despite its odyssey of 4.5 billion miles over the course of 12 years, Voyager is only 21 miles off course, an error not due to Voyager, but to a miscalculation of Neptune's orbit by Earthlings. As this last close encounter nears, Voyager's masters are very pleased with the state of their craft.
The spacecraft is working as well now as it ever has. I think the electronic parts have held together extremely well. We didn't know back before launch what it would take or whether a spacecraft would survive for 12 years because we'd had no spacecraft that had lasted that long up to launch. And I think we're all pleasantly surprised.
But the 12-year journey of Voyager has not been without incident.
We lost one of the Voyager receivers shortly before Jupiter. The Voyager 2 receiver died on us, and we were fearful for a while there that if the second one died, we would be without any ability to command or program the spacecraft. Fortunately, the secondary receiver has proved hardy enough to last through all of these years since that first loss, and it has not severely restricted our ability to program the spacecraft.
While flying by Saturn, Voyager 2's camera platform jammed. However, engineers at JPL got it working again. To get all the pictures and data back to Earth takes 4 hours to make the trip. Because Voyager is so far away and its signals so weak, each command is now sent 6 times. And NASA has also augmented its deep space network, which receives and sends Voyager signals. NASA's antennas in Australia, Spain, and California have been enlarged, and additional ones in New Mexico and Australia have also been added. After its Neptune mission finishes, Voyager's cameras will be shut down, but its other instruments for measuring magnetic fields and ultraviolet light will continue to work for perhaps another 25 years. After that, the nuclear battery which powers the craft will give out, and Voyager will go silently off into deep space. This afternoon, excitement was building at the Jet Propulsion Laboratory in Pasadena, California. Edward Stone, the chief scientist for the Voyager mission, released the first photos enhanced to show Neptune's rotation.
This is it. This is the 24 hours we've been waiting for. This is really the first time that we've had the capability to do this kind of image reconstruction in this kind of time scale. You need basically a supercomputer capability. And so this film you're going to be seeing is essentially the first of the products. So if we could have the film. Now this is a single image which is rotating, so it's not dynamical. In other words, you're seeing the same thing over and over again. You're not seeing 6 separate Neptunian days. Eventually, of course, we should be able to do this with the atmosphere evolving rotation by rotation. That's what we're really aiming to be able to do. But you can already see, of course, the small dark spot and the great dark spot. You can also see the streamers, the cirrus, which is associated with the great dark spot at this particular latitude. You can also see that there's a cirrus streamer up in the northern hemisphere. Your eye begins to pick up some patterns with this kind of a presentation that aren't necessarily so obvious when you sit and stare at the images one at a time. And of course, once we can actually make this into a time-lapse movie where the atmosphere is actually moving, and we have that data, it will really be a very valuable tool, as well as a very beautiful thing to look at.
Joining us now from Washington is Richard Berendzen, an astronomer and president of the American University. He's also a member of NASA's Exploration Task Force. Tim Ferris is an astronomy professor at the University of California at Berkeley and the author of Coming of Age in the Milky Way. He joins us from the Jet Propulsion Laboratory in California. Dr. Ferris, as an astronomer, what do you feel when you see that computer-enhanced reconstruction of Neptune revolving?
Well, I'm really a journalist more than an astronomer, but it's marvelous, isn't it, the way that picture gives you a sense of the enormity of the planet. And that's something that isn't always immediately evident in these encounters, that we're not just looking at pictures or recording scientific data. We are, in a very real sense, visiting sovereign worlds other than our own world. Wildly different worlds, but planets that tell us, in turn, a good deal about the planet we live on.
Dr. Berendzen, how do you feel about it? Are you becoming blasé about events like this?
How could you be blasé about a thing like this? First of all, we're looking at an object almost 3 billion miles away. It takes the light more than 4 hours to get here. We're looking at a device, through a device that was designed to go to only 2 planets. It's now taking in 2 more. It's traveling at about 25 times the speed of a bullet. It's looking at a light intensity only 1/1000th of what we have here on Earth from the sun, and yet look at the photographs, and we've now found weather where in essence there should be no weather. After all, it's heat that drives the weather. And that far from the sun, it's minus 350 degrees Fahrenheit. How then do we go about getting winds of 450 miles per hour?
I'll come back to that in a moment. I just want to ask you, of what is this the equivalent in human exploration, would you say, this reaching to the very edge of our solar system?
Oh, goodness, we're with Marco Polo and Magellan, and tonight we will be with Columbus as we step off into the New World for the first time. But unlike Columbus, we will genuinely know where we are and sense the true importance of it.
Is that too romantic, Dr. Ferris?
No, I don't think it is at all. You know, when you think about how different Neptune is from our world, some of the photos that we've been looking at today, for instance, of the great dark spot,
Let's go to the first of those photos, the one with the dark spot, and look at it while you're talking about it, Dr. Ferris.
Now, you know, if you were to imagine yourself in a balloon hovering over that spot on the surface of Neptune, overhead a brilliant blue sky stretching off to a horizon hundreds of miles away, far overhead those white cirrus clouds that we see in the photograph that are not 5 miles above us, as cirrus clouds are here on the Earth, but perhaps 30 miles or more overhead. And then down below us from our balloon, we would see this enormous cyclone, the great dark spot, nearly the size of the Earth itself, with winds moving through it at hundreds of miles per hour. It's a scale and a magnificence of nature with which we are only acquainted in the slightest prior to the Voyager mission and other missions like it.
So that is a big storm we're looking at in that dark spot.
Yes, in these big Jovian planets, as they're called, storms can last for centuries, evidently. And this appears to be one of these great stable cyclones that sets up shop for we don't really know how long. In the case of Jupiter, the Great Red Spot has been in existence for over a century now.
Now, if that's how do you explain Dr. Berendzen's point of how do you get storms and winds like this with so little heat, with such great distance from the sun?
It's an excellent question. It means that there must be an internal heat source in Neptune, stronger than had been thought. This planet is full of surprises. If I could give you an example from here at JPL, we have just learned that the Voyager spacecraft has passed into what is called the magnetosphere of the planet Neptune, a kind of bubble in the solar wind that is created around the planet by its magnetic field. Now, this encounter with the magnetosphere, came almost a full day later than had been expected on the basis of theory. That's very interesting because it tells us that the magnetic field of the planet is much weaker than had been thought, and that in turn challenges our understanding of the internal mechanisms, the way this planet is made up and how it acts deep down beneath the cloud covers. So surprises like this are coming in almost hourly now here at JPL, and that's the
What
purpose.
does that say to you, Dr. Berendzen?
Well, what it suggests is that it's along with so many other things we found we didn't know. We knew of 2 moons. We didn't know of the other 6.
And 2 more just discovered today.
That's right. We did not know that the rings were complete. We knew that there was perhaps a ring arc or 2, and now, of course, they're finding clumpy rings. We did not know what the real rotation rate would be of the planet, and now by studying the magnetic field, we find that the rotation rate of the outer part of the atmosphere is not the same as that of the more inner part of the planet, which is more or less what you'd expect because it's sloshy inside. The planet is largely made of gas, hydrogen, helium, with a lot of methane in the upper atmosphere to be sure, but somewhere down inside, some ice and perhaps rock. More and more we find that the planet is not quite what we'd expected, although our theories and our observations from Earth gave us at least a first approximation.
Let's look at the second picture, the one that shows it with a very pink edge, at least on this monitor, and at that very white spot. Tim Ferris, tell us about what this shows.
This is a false color view of the planet through a filter that attenuates light as reflected from the element methane, which is a great deal in Neptune. It is that filter that creates, among other things, the appearance of a pink edge going around the planet. In this view, blue reads out as lower altitude and white as higher altitude. So you can see the dark spot we've been talking about looking very white here because those cirrus clouds are hanging over it at a high altitude, whereas most of the surface of the planet is lower. So thanks to photos like this, it's possible to begin to understand the third dimension of the surface of these giant planets as well.
Let's look at our third photograph, which is of the moon Triton. What does this photograph tell us?
Now this photo, which is also a bit false color, if you'll notice toward one side, this satellite appears dark. That's not a shadow. It's a real difference in the surface composition of the satellite. For some reason, part of the surface is much brighter than another part. The reason really isn't understood, but things of this sort are very interesting in studying the solar system. Triton, like our own moon, is gravitationally locked, so it always presents the same face to the planet that it orbits, Neptune. Mm-hmm. When you get a locked planet like this, it means satellite means one side of it has a different environment than the other. One side is facing the planet and one away. And the satellite may evolve differently as a result. For instance, meteorites. But
Voyager is going to show us the other side of this moon as it goes by, is that correct?
It'll show us some more of this, and more importantly, it'll show us, beginning as early as just a few hours from now, much higher resolution images of the surface. So we should be able to begin to see why it is that part of the surface is dark and the other part light.
Dr. Berendzen, any observations on the photo of Triton? I mean, that's the moon astronomers have known about through telescopes for a long time.
Well, it is indeed, but the thing which is so especially exciting about it is, of course, that it has an atmosphere. Now, it's one of the very few in the solar system that we know about that has an atmosphere.
How can you tell it has an atmosphere?
Well, you could tell that by looking even from the Earth's surface because it has a bluish tint, which was probably coming from the methane. And now, of course, once we're getting closer, you can observe that better. And once we fly by later tonight, you can, in fact, even peer through the atmosphere looking back towards the Earth as it goes with the moon in between the space probe and the Earth. Now, what we expect to find, of course, is that we'll be able to see 10 times better than what was seen so far. And when you do that, we'll be able to see the surface features on the moon. It should be quite fascinating. You might even find glaciers made of nitrogen. You will probably not find the lakes or rivers of nitrogen flowing that some people had thought about theoretically a few weeks ago because it turns out to be too cold.
Tim Ferris, describe the sequence of events that happens from now on this evening. We're through the magnetosphere, the sort of magnetic envelope. What happens now?
I made a few notes on some of the high points coming up. At 9 p.m. Eastern Time tonight, there'll be high-resolution pictures taken of the rings of Neptune. These are very high resolution indeed. They get down to only 5 meters, so an object the size of a bus could be detected. At 1:11 in the morning tonight, there'll be high-resolution pictures made of Triton, the satellite we've just been discussing. That resolution will show objects as small as 6 miles across. At 3 a.m., the Voyager spacecraft will pass through the ring plane of Neptune. It's thought to be a safe crossing, but no one really quite knows what material lies in the plane. So as a safety precaution, the cameras are turned away from the direction of the spacecraft's travel. So much in the way that if you were walking into a hailstorm, you might walk backwards to protect your face as it passes through the ring. So if there is some dust there, it'll be less chance of it damaging the camera lenses. At 4 a.m. will come the closest approach to Neptune, only 3,048 miles, distance closer than distance between London and New York.
Is that
it passes
just
over the pole.
Compare that distance to the kind of pictures we're used to of satellite pictures from Earth. I mean, is that well within the range of our really high-resolution satellite pictures over the Earth?
Well, it won't be that sharp because, of course, the Earth satellites make intrinsically such higher resolution pictures. But it's closer than a lot of satellites get. The synchronous satellites carrying, for instance, this TV program are much further away than 3,000.
You mean the picture we're seeing you on right now, coming from Pasadena to New York, that satellite is farther away from Earth than Voyager will be from Neptune later tonight.
That's right. Those satellites are 24,000 miles high, so this picture has traveled 50,000 miles as opposed to only 3,000 miles distance between Voyager and Neptune.
Dr. Berendzen, finally, you were talking about what a technical achievement this is. If this were up to the moment, state-of-the-art technology, what more would we get out of it?
Oh, my goodness, it's hard to say. We're, after all, dealing here with a computer that was 1975, and it was designed only to go to 2 planets. Would probably be able to see more details, would probably be able to give more commands. But I think the dazzling story here is not what can't be done, but what has been done. And realize that we're now getting the last of the picture show. Within only a few hours, the movies will be over, and then the spacecraft will leave, and ultimately it will leave the solar system. And yet it will continue literally forever, long after we have perished. The Great Wall of China has perished. It'll still be out there.
We can't continue forever right now. Dr. Berendzen in Washington, Dr. Ferris in Pasadena, thank you both.
Again, the main stories of this Thursday. The Polish parliament elected a non-communist prime minister. He is Tadeusz Mazowiecki, a leader in the Solidarity labor movement. And Cincinnati Reds manager Pete Rose was banned from baseball for life. Baseball commissioner Bart Giamatti said there was ample evidence Rose bet on baseball. Good night, Robin.
Good night, Judy. That's the News Hour tonight, and we will be back tomorrow night. I'm Robert MacNeil. Good night.
For the latest on the epic exploration of the outer solar system, we go live to CNN's Dan Blackburn. He's at the Jet Propulsion Laboratory in Pasadena, in California. Dan?
Well, Patrick, it is not quite nail-biting time here yet, but it is getting close. The Voyager spacecraft does face some hazards as it races around Neptune, coming within 3,000 miles of that planet's cloud tops, and then flies on within 24,000 miles of the big moon Triton. However, the Voyager team members say that they are confident the spacecraft will come through with flying colors. Earlier today, the Voyager scientists announced that the cameras on the spacecraft had uncovered 2 more moons at Neptune, those to the right in this picture, bringing the total there now to 8. Both new moons, however, are quite small and fairly close to the planet. The cameras also showed us what is likely to be the best picture of the huge storm system known as the Great Blue Spot. This giant storm is as big as our Earth and may have been raging on Neptune for centuries. The scientists now are working on round-the-clock shifts, and some of them are operating on adrenaline. As of now, for the Earthbound scientists, Voyager's close encounter with Neptune is becoming something of an endurance contest, but also a once-in-a-lifetime opportunity.
This is all rush. I mean, only 2 hours of sleep now, and I've been coming in at 5 the past couple of days. I'm not going to go home now.
I was in on the ground floor of an exploration of the entire solar system.
Us scientists are sitting here just kind of staggered by the whole thing and having a lot of fun. But if people start forgetting the name of the planet by Friday or Saturday, that's why.
Okay.
Meanwhile, the Voyager cameras have shown scientists something they have not seen anywhere else during the spacecraft's grand tour: shadows cast by clouds. Yet that is just what this picture shows at Neptune. It is believed that shadows are due to a 30-mile gap between methane clouds high in Neptune's atmosphere and a blue cloud deck far below them. Such a situation clearly is a rarity. CNN will have live coverage of the close encounter period with Neptune, a look at what's going on, the people, the spacecraft, and, of course, all the discoveries yet to come. That'll begin at midnight Eastern Time. I'm Dan Blackburn, CNN Live at the Jet Propulsion...
Now you ask. Well, CNN's Dan Blackburn is joining us live. He's at the Jet Propulsion Laboratory in California. Dan?
Well, Patrick and Donna, right now, the Voyager spacecraft is passing through the shadow of Neptune. It's about 7,000 miles above the cloud tops, having brushed by at a distance of a little over 3,000 miles. Now it's heading out away from the planet and racing on toward its close encounter with the big moon, Triton. That'll take place in about 5 hours. All the while, its cameras have been clicking and the instruments ticking, sending back pictures and data to Earth, pictures and data which will arrive here early in the morning.
Earlier, the Voyager scientists announced they had found 2 new moons at Neptune. Both are small, 30 and 60 miles across. They bring to 8 the total number of moons found at Neptune so far. Meanwhile, a moon found previously and labeled N1 now has been determined to be the second largest at Neptune, and it is not round, but irregular in shape.
This object, because it is out of round, has remained rigid since its formation. Now, we don't know when it formed, but had it partially melted, it probably would have pulled itself into a more spherical shape.
In another surprise, Voyager's cameras for the first time saw cloud shadows unlike at any other planet. It is believed these shadows are due to an extraordinary gap of at least 30 miles between the high white methane clouds and the blue cloud deck. The narrow-angle camera also provided what is likely to be the best close-up we will get of Neptune's great dark spot, a raging storm system big enough to swallow the Earth. The clouds above it are formed by methane pushed up from Neptune's interior and then condensing higher in the atmosphere. This new color photo of the intriguing moon Triton also was made available. The picture has been computer-enhanced to highlight more details of the modeled moon where the surface, especially near the equator, may be covered with methane frost. As for Neptune's somewhat murky rings, the scientists now say they are convinced that at least 2 such rings exist. The larger one still appears to have a 10% gap in it, but that gap probably is filled with very fine, hard-to-see material.
With me now is British astronomer Patrick Moore. Patrick, we were talking about rings. Do you think as the spacecraft moves away from Neptune and starts looking back, it'll see any more?
We could. I think there may be a certain element of luck in it. Remember, even the main complete ring is so faint, it's right on the threshold of Voyager's visibility. And I think it may be just where the cameras are pointing. What I think we will find out is whether what we used to call the ring arc is actually a part of a complete ring or not. There's only a certain amount to be filled in, but I think that'll probably be done.
Now, of course, we've seen 2 new moons recently. Will there be some more as we start scanning back and look? There ought to be some around these rings.
I'll be very surprised if there are not. If I had to make a guess, I would say that the grand total is going to be about 10. But the really interesting thing is to find out whether any of these moons are shepherds to the rings, keeping the ring particles in order, so to speak. That happens with Saturn's rings and with some of those of Uranus. And we expected to find them in this strange diffuse ring of Neptune. So far, only 2 shepherds have been found. I think we may find more, and I'm quite certain they'll be looking very hard for that.
I think the peak of excitement now for many people is coming up when the spacecraft zeroes in on Triton and starts snapping away at that surface, which we're clearly going to see.
I think for all of us it's going to be the highlight of the entire mission. See, we were afraid to start with that we might see nothing more than the top of the layer of cloud, as we did with Saturn's main satellite, Titan. But Triton's atmosphere is so thin we can see through it. We can actually see the surface. And already we know it's multicolored, and the strange features there we can't understand. It's certainly a lot of methane ice, and methane ice isn't like ordinary water ice. It tends to flow. And therefore I think we're going to find that the surface of Triton is totally unlike any other surface we've seen. But one thing we're not going to find is oceans of nitrogen, because we now know that since Triton is smaller and colder than we believed, it's below the limit in which nitrogen can stay liquid.
We've had some recent images come back from the Voyager cameras, pictures like this, for example, that show streamers. I mean, not just clouds around the great dark spot, but streamers racing across the face of the planet.
The weather systems on Neptune, if you can call it that, are remarkably interesting. See, those cirrus clouds, of course, they're not cirrus water ice clouds, they're almost certainly methane crystals. They're very high, and there's something like a 30-mile clear gap between those bright clouds and the main cloud deck, which we didn't expect. Something very strange there about the airflows, and I've no doubt the rotation periods are different as well. I mean, the scooter laps the big spot in a couple of days.
Patrick Moore, thank you very much for joining us. I'm Dan Blackburn, CNN Live at the Jet Propulsion Laboratory in Pasadena. Now back to you, Patrick and Donna.
Thank you, Dan. A chronology of Voyager's historic flyby shows the moments when scientists hope it will make more discoveries about Neptune.
Here's what is going on with the spacecraft from now through the next few hours and into the ages, for that fact. We point out that these are the times when the events actually will happen. The radio signals won't reach the Earth for 4 hours. At 12:06 Eastern, or just about now, Voyager appears behind Neptune as viewed from Earth. Then 49 minutes later, at 12:55, the spacecraft emerges back into view of Earth. At 1:29 a.m., Voyager crosses the plane of the arc rings a second time. And then at 2:06, Voyager's cameras will start taking high-resolution pictures of the moon Triton. At 4:40, Voyager takes its best pictures, in fact, of Triton. By this time, data from the flyby will have been on Earth for about 34 minutes. At 5:14, Voyager makes its closest approach to Triton.
At midnight Friday, Voyager will have traveled 930,000 miles beyond Neptune. By October 2nd, the Neptune encounter officially ends as the spacecraft hurtles out of the solar system.
Looking ahead now through the eons, and I mean really looking out ahead, 40,000 AD, Voyager passes within 1.7 light years of the star known as Ross 248. And then, in 296,000 AD, it comes within 4.3 light years of the star Sirius, or the dog star, as it is known.
And still ahead in this special edition of Newsnight, a closer look at the Voyager spacecraft itself.
And in our Newsnight 900 poll, we will ask if the expense of the Voyager mission has been worth it.
Hello? Joseph? What? Amalgamated Central? Hostile takeover? No way, Jose. I'll figure this deal out so fast on my Head Start 3 computer, they won't know what hit them. I got the whole picture in VGA graphics, okay? We spin off our company in Caracas, and Amalgamated is protected. Get it?
The Head Start computers, whoever you are and whatever you do, they're built to be compatible with you.
A few words on business and change.
The journals are daily, and that gives you a real competitive advantage. It's very tough out there, but it's also very exciting. We want to be the best ally that you've got.
Today's Wall Street Journal. Faster, tougher, smarter. Call 800-334-6600 for this special journal offer. 12 weeks, just $29.75 with a money-back guarantee. Call 800-334-6600 now for the Wall Street Journal.
If you enjoy getting away to Las Vegas, Atlantic City, Reno, Lake Tahoe, the Caribbean, Players Club was made for you. You know, your membership card gets you up to 60% off your room in first-class places like Resorts International. 50 to 70% off your airfare. 25% off meals and drinks, and another 50% off shows and entertainment. Call for free information, then make up your own mind. New members get 2 free room nights in Las Vegas or Atlantic City.
Tomorrow, Wanted, creative concepts for cleaning up the Great Lakes. Billions of dollars are needed, and the resources aren't there. Who's going to take responsibility? On CNN's Daybreak, 8 Eastern, tomorrow.
What exactly is Voyager, and how does the spacecraft send pictures of Neptune and other information back to Earth?
CNN Science Editor Charles Crawford is joining us now. He's live at JPL to explain all of this. Charles?
Patrick, this is a full-scale model of Voyager, and extending out from underneath that high-gain antenna is the scan platform, the business end of Voyager. On it are mounted many of the instruments that have been collecting 5 trillion bits of data and collecting it and sending them back to Earth. It's movable in 2 directions. It can move sideways, and it can move up and down. That allows you to point or direct any one of the instruments very precisely and accurate at the desired target. This is the gold-plated mirror of the infrared detector. It measures heat emitted from the planets and their satellites. Then over here to the left is a photopolarimeter. This is a telescope with special filters in it to measure light and how it is scattered off the surface of the planet and through its atmosphere. Then above the photopolarimeter, the narrow-angle camera and the wide-angle camera, the two cameras that have been sending back the never-ending series of spectacular pictures from Jupiter, Saturn, Uranus, and now Neptune. One of the questions that's often asked is, why is it that it's so long before we see what Voyager is looking at from the far reaches of our solar system?
First, there is the light problem. There is only 1/1000th as much light on Neptune as Earth, meaning high noon on the giant gas planet is like dusk on Earth. That means Voyager's cameras must make a time exposure of as much as 1 minute. The picture actually is sent as a digital signal, a kind of electronic code. Even at the speed of light, 186,000 miles per second, it takes 4 hours and 6 minutes for the signal to travel the 2.7 billion miles to Earth. The signal is 20 billion times weaker than the power used to run a digital watch. It takes the huge deep space network antennas in Australia, Spain, and California, along with the 27 dish array in New Mexico, to receive the feeble signal. The electronic code is sent to the Jet Propulsion Laboratory, where it's deciphered to begin the picture-making process. A number of the same pictures, taken through different filters, are needed to produce a computer-enhanced color photograph. So, from the time Voyager begins transmitting the most recent image data, it will be about 7 hours before the world is treated to the never-before-seen worlds of our outer solar system.
And it takes about the same amount of time to receive and process data from the instruments at the other end of Voyager. That's the canister there where the 43-foot magnetometer boom is housed and stored and then is extended. And this is the rabbit ear plasma wave antenna, which scientists hope will tell them when Voyager has actually left our solar system and begins traveling through interstellar space. Donna and Patrick?
You know, Charles, I think, I don't recall whether it was your report or it probably was. We had the report about the mock-up that you're standing in front of being, of course, looking like something that was just built, a very fresh-looking instrument. You might want to describe for our viewers what the actual Voyager 2, the condition that it is in now, as I guess it's somewhat battered by various particles that have hit it over this 12-year trek.
Well, it's lost some of its computing power. It's been described as having arthritis and deaf in one ear and blind in one eye.
Yeah. Hasn't it also, though, gotten a couple of, I mean, it's actually got some dented fenders from a few objects hitting it.
You know, though, Patrick, the remarkable part is that the scientists have been able to recover in almost every instance and through some very fancy and intriguing computer software programming, overcome almost every obstacle that has been put in its way with the damage that has been done to the Voyager.
Okay, Charles Crawford. We'll be talking, of course, more with Charles later.
Well, Voyager may seem like a bargain in exploring the cosmos by the standards of manned space travel. Together, Voyager 2 and its predecessor in the solar system, Voyager 1, have cost $865 million for the spacecraft and the work on Earth.
Well, that comes to about 20 cents a taxpayer per year since the program began. In our Newsnight 900 poll tonight, we ask, is the Voyager mission worth the cost?
If you think yes, the knowledge gained is worth the investment, call 1-900-720-6110. If you believe no, it has not been worth the money, call 1-900-720-6111.
Remember, the call will cost 50 cents. Results at the end of Newsnight.
Our special live coverage of Voyager 2's historic flyby of the planet Neptune.
The spacecraft is now at the peak of its rendezvous with the mysterious planet, and for the very latest, we're going to go to CNN's Dan Blackburn. He is at NASA's Jet Propulsion Laboratory in Pasadena, California. Dan?
Patrick, Donna, the spacecraft, for all we know, is performing absolutely perfectly. The closest period of encounter with Neptune is over. It is now headed away from the planet and on toward the giant moon Triton. We won't know how well it went for quite a while yet. It takes over 4 hours for the signals to get back here. And one man who's waiting very much to see those signals is the leader of the imaging team, Brad Smith. Brad, what are we looking for?
Well, we're coming up with a very close encounter with Triton tonight, and that's going to be probably one of the highlights of the mission. It's turning out to be an extremely strange body, something of a type we haven't seen before, and we're looking very much to those very, very high-resolution pictures that we'll be getting sometime early in the morning.
Now, we're looking at a NASA animation of the kind of pictures you'll be taking, and I gather this represents where you'll be focusing. Obviously, you want to look at where there's light on Triton.
Yeah, we're looking right in close to the terminator. That's the sunset line there, and that will give us our best opportunity to see craters or other types of relief on the disk.
Do you think there are craters there?
That's a good question. Right now, it looks as though it's a stranger type of topography than just a cratered surface, and that, of course, really piques our interest.
Well, I would think, as we look at this latest color picture of Triton, that if it has methane ice on the surface, which can flow, that craters, impact craters, would tend to be erased.
That's the idea. The methane ice and nitrogen ice may be kind of mushy, and that would tend to allow the craters to flow out, yeah.
Brad Smith, thank you very much for joining us. I'm Dan Blackburn, CNN Live at the Jet Propulsion Laboratory in Pasadena. Now back to you, Patrick and Donna.
All right, Dan, thanks so much. And still ahead in this special edition, News Night, we're going to be talking with a man whose idea made the Voyager mission possible.
And we'll have more late pictures from Voyager 2.
Off a 12-year odyssey, an odyssey that began modestly and mushroomed into one of the greatest feats of exploration in human history. When Voyager 2 climbed into space August the 20th, 1977, its mission was mighty indeed. The space probe was set to spend 4 years exploring the secrets of 2 planets, Jupiter and Saturn. Now, 12 years and 4 planets later, Voyager 2's mission has gone from mighty to miraculous. With its sister ship, Voyager 1, following close behind, Voyager 2 set out for Jupiter. Both sent back pictures from the huge planet, observed its giant red spot, then used Jupiter's gravity for a slingshot assist to Saturn. It was there the probes went separate ways. Voyager 1 moved on to inspect Titan, one of Saturn's moons. To do so, its path, or trajectory, had to be bent upward, making additional flybys impossible. But Voyager 2 used Saturn's gravity to warp its trajectory once more, this time for a close encounter with Uranus in January 1986. The spacecraft beamed back pictures of moons never seen before. Then Voyager used Uranus for a final gravity assist to hurl it toward Neptune in what amounted to an outstanding celestial billiard shot. On October the 2nd of this year, the Voyager-Neptune encounter formally ends. Then the amazing space probe will sail off into the deep night of space.
CNN science editor Charles Crawford joins us again now from the Jet Propulsion Laboratory in Pasadena.
And with him now is one of the people who helped line up that celestial billiard shot, as we referred to it. Charles?
Well, you wouldn't believe it, Patrick, but it all happened almost a quarter of a century ago. And with me is Gary Flandreau. He was one of the key players 24 years ago when he was an intern here at Jet Propulsion Laboratory. And you were a key player in figuring out both when to go and how to go. Tell us about it. First, tell us what it was like 24 years ago.
Well,
what were you doing?
A young chap, a graduate student at Caltech, and I was enjoying working here summers, and I was given the job of looking for these outer planet missions, looking far beyond what we thought we could do at that time. And I, fortunately enough, was in a position to find this mission.
There you are.
And, oh, that's me, yes.
24 years ago, as an intern here?
That's how it was, yes.
And a graduate student.
Yes.
Gary, tell us how did you go about figuring out when to go?
Well, this was a matter of drawing a lot of pictures of the outer solar system, watching how the planets moved relative to one another. And that's how I first found this mission, was by noticing that all of these outer planets were located on the same side of the sun in the late 1970s, and that gave us an opportunity to fly past 4 of them in one flight, which was, of course, a tremendous economy. And I think that's what made this mission work, was that we could do 4 planets with one spacecraft.
So you actually knew when Voyager left our Earth orbit where it was going?
Oh, absolutely, yes.
Now, tell us about this gravity assist, or the so-called slingshot effect.
Okay,
how did you make the billiard board shot?
Well, this is an important part of it, because it's not only a matter of deflecting the trajectory at each planet, but it's also a matter of using some extra energy that you gain as you go past. The planet pulls the spacecraft with it like a slingshot and gives it extra energy. And that's what gives us the very fast flight paths to these planets. Now, if we made a direct flight from the Earth to Neptune, we would be talking about a 40-year flight time.
What was it like when you figured it out?
Well, that was a wonderful feeling. I could see that here we had something that would really make those outer planets come within our reach. I felt that this might be difficult to sell to NASA because we were having trouble getting to Mars at that time. But I thought this was the most wonderful thing that I could imagine. And I imagined each of these flybys and how that would be. And I imagined this moment in time that we're experiencing right now. And it was a wonderful thing.
And what's it like today to come back to the Jet Propulsion Laboratory?
It's just an unbelievable experience to actually see it happening the way I imagined it could 25 years ago.
Is it good now that it's kind of a terrible letdown that it's all over?
No, not at all. I don't feel let down at all.
Why is that?
I'm exhilarated because it isn't over. It's not like it plunged into the ocean or something. It's plunging now into the vastness of interstellar space, and at some very distant time it's going to pass by another star. It'll be the first man-made object to reach another star.
What do you think it's going to tell us before it loses its power now in about another 25 years, right?
Yes, I think they feel probably about 20 years or so. During that time, we're going to learn a lot about regions of space that we know virtually nothing about, the regions where comets are formed, the Oort region. So hopefully we're going to get some data back that'll show us what's there in terms of particles and magnetic fields and things like that.
Gary Flandreau, thank you very much for joining us.
You're welcome.
Patrick and Donna, back to you.
Yeah, Charles, before you get away, of course, we've all pointed out it was '77 when this space probe was launched. And we marvel today at the technology of cameras and the instruments that we have. Have you had a chance to talk with any of the experts there at JPL, including even your guests that you just talked with, about how much greater this probe might be if today's camera technology were aboard, today's radar and various devices for checking out the surface and content of a planet's atmosphere?
Let's ask the expert himself. The question is, how much more information might we have gotten if we had today's sophisticated technology compared to what was on that craft when it left in 1977?
Well, I think we've really only scratched the surface of what we could have learned. That's a difficult question to answer, but I think we could have done a lot more. We could have dropped probes into the atmospheres and actually measured the gas content and many more things that we could have done with the technology we have right now as compared to what we had back in the 70s.
And I suppose we should mention, Patrick, that that in fact is going to happen with the next spacecraft that's launched, Galileo.
Mm-hmm. Okay, Charles, we'll be talking with you again, of course, as we continue with our special here, a special edition of Newsnight.
And still ahead, it is a joyous night for the people who made the Voyager mission possible, and we'll turn the spotlight briefly from Neptune to them.
And a visual roundup of Voyager's greatest moments.
You still have time to vote in tonight's Newsnight 900 poll. Our question is the Voyager...
About 30 minutes ago, the Voyager 2 spacecraft was scheduled to swoop to within 3,000 miles of the planet Neptune for its closest look yet.
Let's go back to CNN's Dan Blackburn, who's standing by at the Jet Propulsion Laboratory in Pasadena for the very latest. Dan.
Donna, the excitement level here remains high. It'll be still almost 4 hours, 3.5 hours roughly from now, before we know exactly how Voyager did on its close encounter with Neptune. As you noted, the spacecraft has now passed that point of close encounter. It's sort of saying farewell to the blue planet and moving on toward the pink moon, and that is the moon Triton. It will come within 24,000 miles of that moon and get a very good look at the surface of one of the more interesting objects in our solar system. With me is the leader of the imaging team for Voyager, Dr. Brad Smith from the University of Arizona. And Brad, earlier today, we were shown a very interesting picture of Neptune that was assembled by a large supercomputer that shows us kind of the way that Neptune, I guess, rotates as you look at it from this point, although I gather it's not altogether what we would see.
Well, this is a computer-generated image, and just there you can see the great dark spot rotating by. It's been assembled by a computer and gives us a just sort of a view of what we would see if everything was speeded up and it were rotating in front of us.
Now, one question that's occurred to some people is, on the real-time monitors that are scattered all over this lab and that many of us have been watching, we aren't seeing any interesting pictures at all. In fact, we aren't really seeing much of a picture. Why is that?
Well, the spacecraft does many things, and it's performing another type of operation at this moment, which doesn't involve imaging. It's another type of measurement, and so there is a hiatus when we don't have images coming in. But another half hour or so, we should have more images.
Now, this is the image, of course, that we have been looking at, but this picture came in much earlier, and I wanted to ask you, you can see these streamers coming off the dark spot on it. What are those?
Well, we've been puzzling over those. They're actually sort of cirrus-type clouds, very, very high above a clear atmosphere. Apparently, the atmosphere is of the order of 75 miles higher. These clouds are 70 miles higher in the atmosphere than that lower cloud deck that you're looking at. And you can see them streaming up toward the great dark spot or away. The problem is we still are unable to measure those velocities and tell exactly which way those winds are blowing.
And that's about as long a tail as I've seen coming off that spot. Now, here's the blue spot with some of those same streamers. They don't seem quite stretched out as far, so obviously this is partly a function of when you see it.
They're changing very rapidly with time. In fact, so rapidly it's very difficult for us to keep track of them. You can sort of think of them as, like lenticular clouds that you see over mountains. The winds are blowing very rapidly, but the cloud seems to stay stationary.
Brad Smith, the imaging team leader for the Voyager project, thank you very much for joining us. I'm Dan Blackburn, CNN Live at the Jet Propulsion Laboratory in Pasadena. Now back to you, Patrick and Donna.
All right, Dan, thanks very much. Well, at best, the gangly 1,700-pound spaceships could be called hardy. Cute, they really are not. Well, nonetheless, hundreds of people across the country consider Voyager 1 and 2 their mechanical babies. And next week, when Voyager 2 wraps up its grand tour of Jupiter, Saturn, Uranus, and Neptune, many people will feel lumps in their throats. Mission design manager Charles Colhays will be among them. He was 39 when he began working on Voyager. Now he's 53, and he's experienced the highs and lows of the mission. And over the years, he's witnessed changes, not just in the Voyager mission, but in the lives of its creators and engineers. Dan Blackburn spoke with Colhays at length about these final days of the Voyager mission.
We look back, and Neptune is shrinking in the distance. And remember, it will be mostly a dark side we'll be looking at, only a narrow crescent. A lot of us are going to be very sad because we know that the grand tour has come to an end, kind of the last great picture show. And it'll be definitely a letdown. And we kind of joke about it. We're not going to jump off of cliffs, but we're going to be quite sad. People even identify, you know, their first child was between the first two Jupiter encounters, and then Susie came along just before the Saturn encounter. Obviously, people break up, people get together, some people die, people are born. You know, a period of a decade and a half, a lot of things happen. And that's also that introduces the human element amidst the scientific endeavor. There have been ups and downs all along the way. I mean, even when Voyager 1 was launched, there was an underperformance in the Titan burn that almost caused us to fall short of reaching the injection conditions for Jupiter. In fact, when the upper stage shut down, there was only 3.5 seconds of fuel left in the tanks. Now realize if Voyager 1 had not made it to Jupiter and its moon Io and Saturn and its moon Titan, then Voyager 2 would not have had the green light to fly the grand tour. I would thank these robots. They're not quite as human as R2-D2, but they're important to us. I would thank them for performing so well. I would wish them well on their lonely trek. Now you realize they're both escaping from the solar system. No more planetary encounters. They will wander basically around the core of the Milky Way galaxy, only separating from the sun at a very slow pace. Although there are gold-covered copper phonograph records on board, it's unlikely the spacecraft will be intercepted, and therefore they're on their own forever. And I will wish them well, but be sad that they will have such a long and lonely trek.
We want to go back to Pasadena and visit once again with Dan Blackburn, our correspondent. He has been covering Voyager trip for the last 12 years. Dan, Mr. Colhays talked about the changes that he's seen. How about you?
Well, there have been a lot of changes, Donna, and I think that one of the more interesting things has been the fact that the interest of the public on this has sort of wavered up and down. Initially, at Jupiter, everyone was very excited. Of course, Jupiter was an exciting planet. At Saturn, everyone knew about the rings at Saturn, and there was some enthusiasm there. Uranus was kind of, well, I don't think the scientists would call it ho-hum, but let's face it, it wasn't the most exciting stop in the entire tour. But this time, the turnout of people, the press contingent, the people walking around here, I think this is on a par with when the Viking spacecraft landed on Mars back in the mid-70s. So this has been an exciting end to this adventure of 12 years.
Well, Dan, you know, in your interview with Mr. Cole Hayes, he talked about some of the personal lives of people who have been working on the project. Since you've covered it from the outset, how about you? What has happened with you over this dozen years since you began covering this?
Well, a great deal, but I'll tell you probably in one aspect the most interesting part of it is that during the encounter with Uranus 3 years ago, I became engaged to a woman who was the producer of the part of the NASA coverage of Uranus, and we got married the following year. So there have been definitely deaths, marriages, and births throughout all of this.
A celestial romance, no less.
Oh, my. Can you think of some moments that really stand out in your mind? I know you've seen a lot of excitement over the last couple of days. Are the scientists really jumping up and down like we've heard?
Yes, they really are. Some of them are walking around looking like the cat that just swallowed the canary. Every time they go up and look at the images coming back, particularly tonight when they're seeing these new pictures of Triton that we have not yet quite seen, they come back down with grins spread from ear to ear, and all they can say are words like terrific, magnificent. And the important thing to remember is they haven't seen the best yet. That's still several hours away.
All right, Dan, we'll be back to you shortly, of course. CNN's Dan Blackburn at JPL in Pasadena.
Still ahead, a late update on the Neptune rendezvous from the Jet Propulsion Laboratory.
And the results of our Newsnight 900 poll, and tonight there's the question. You see what we're asking. Also joining us tonight from the Jet Propulsion Laboratory. All right, we'll get this organized for you in just a moment, folks. Thought we were going one place, but we're not. We're going here. We'll have more on the Voyager for you in just a moment, but first we have our regular science report. Researchers are trying to get a better understanding of global climate. Scientists from 5 countries are participating in a joint venture to discover how plants affect the weather. Jeff Levine reports.
A pastoral setting on the Kansas prairies where nothing disturbs the cow's contemplation of the horizon. This summer it took on the look of an alien invasion, but the instruments and scientists were actually part of a multinational effort to determine how vegetation affects the Earth's climate.
What's the length of the measurement? One measurement.
150 scientists from the United States, Canada, Great Britain, France, and the Soviet Union gathered on the Kanza Prairie near Manhattan, Kansas, to record weather information. This prairie was chosen as the experimental site because it is undisturbed by urban pollution, and several American, European, and Soviet weather satellites routinely pass over it. The scientists will compare satellite data with measurements and information gathered by balloons and aircraft to get a detailed picture of the movement of carbon dioxide, moisture evaporation rates, wind speeds, and radiation of heat from ground to air.
Well, we're really here to look at the effect of the land surface on weather and climate and see if we can better understand those processes and monitor that using Earth remote sensing satellites.
When the experiment is at full speed, 5 aircraft are involved: a helicopter, 2 twin-engine prop planes, a C-130, and a high-flying ER-2 line up under an orbiting satellite and fly over the prairie, recording information as they go. The researchers say one of their primary goals is to relate surface and air measurements to satellite observations taken at the same time.
Ultimately, we feel that the satellites are probably going to be the only really valid way of monitoring climatic change.
Interest in global climate has soared recently because of mounting evidence that the Earth's temperatures are rising. The trend is often blamed on the greenhouse effect, a gradual warming of the Earth's atmosphere caused by gases such as carbon dioxide, CO2 that traps the sun's energy instead of letting it reflect back into space. Experts say a runaway greenhouse effect would cause intense storms, massive flooding, and extended droughts. But there is some hope that plants will save the Earth from that fate.
While we're increasing CO2 in the atmosphere, we can expect the vegetation to do something different. The biosphere is not going to take it lying down. And the indications are that the biosphere is actually slurping up some of the CO2.
As you'll see in our next report, this ambitious project also became a grand opportunity for the meeting of Eastern and Western scientific thought. Jeff Levine, CNN, reporting.
Science and Technology Today is brought to you by the people at AT&T. AT&T, the right choice.
In Pasadena, Mr. John Pike. He is with the Federation of American Scientists. That's a space watchdog group. Mr. Pike, our 900 poll question tonight, we've asked whether folks think the cost of Voyager 2 is worth it. What do you think about that, and what the benefits are to those of us who are back here on Earth?
Well, we've invested approximately $1 billion in this Voyager spacecraft. It's given us a new look at 4 planets, dozens of moons. I think that cost is certainly well worth it. In practical terms, understanding how storms form and develop on Jupiter, understanding how storms develop on Neptune may eventually help us to understand how we get storms here on Earth and improve weather forecasting. So in terms of simply the aesthetic joy of seeing these new worlds, as well as the practical scientific benefit, I think the investment's been well worth it.
And what about the moon, the Triton? I understand that's revolving around Neptune, contrary to the direction that it should be revolving for a moon. I don't quite understand how that. I guess if Neptune is revolving this way, the moon is if it's clockwise for the planet, it's counterclockwise or vice versa.
Right.
Well, why is that? Do they have some speculation?
Well, that's one of the very interesting things that they're trying to understand from this encounter. Why is it that Uranus and Neptune, although they're similar in size, are so very different in appearance? Of course, Uranus turned out to be fairly boring to look at. You have all of these interesting clouds on Neptune that may have something to do with the way the planets were formed, and part of the remnant of that formation process may be the fact that Triton's going around Neptune backwards.
Do you think that after we get through with this mission that there'll be a renewed interest now that will keep this interest up, or that perhaps we may fall back into what some folks said that happened after the anniversary of the walk on the moon, that the interest kind of fell off?
Well, I think that the Neptune encounter is certainly a spectacular finale for this grand tour of the solar system. We have some very interesting missions coming up. Of course, we just launched the Magellan mission to Venus, Galileo mission to go back to Jupiter coming up, and of course the Hubble Space Telescope next year. All of the things that we've seen over the last 30 years have basically been totally new observations, planets that we had never seen before. Now we're embarking on a period of getting a much clearer view of already familiar planets. I think that the discoveries that we're going to be seeing over the next couple of years are going to be just as exciting as the ones that we're seeing this evening.
All right, John Pike from the Federation of American Scientists, the Space Watchdog Group, thanks very much for being with us.
Thank you.
Our Voyager coverage will continue in just a moment, but first...
System, which means it's a high-pressure region, and then we see smaller spots, white spots, which can be seen from the Earth, and then dozens of smaller spots that couldn't be seen at all. And I think it was the abundance of these small, rapidly rotating storm systems, which was really quite surprising.
Jupiter also had the solar system's most surprising moon to date, volcanic Io. Voyager cameras revealed that Io has 8 active volcanoes, one of which hurls out debris at the rate of 200 miles an hour, 50 times faster than Earth's Mount Etna. And there is more.
The surface of Io is covered with a lot of sulfur and oxygen, and something like 1 to 2 tons of that material per second is stripped off by Jupiter's magnetic field as the magnetic field rotates past Io.
Io's dust then creates Jupiter's equivalent of the Northern Lights. Voyager also discovered that Jupiter has a tenuous ring system with a halo effect.
An extended halo of fine particles that is believed to be the result of the charging, the electrostatic charging of the tiny dust particles, and then their interaction with Jupiter's tilted magnetic field. So it is very different in character from the other ring systems.
Of course, the best-known rings surveyed by Voyager were those at Saturn, the ringed planet. Saturn's rings contain chunks of ice ranging in size from small pebbles to objects as big as large houses. Voyager discovered the surprising braided F ring at Saturn, which is held in place by 2 so-called shepherding moons. And these spoke-like features, which scientists believe are caused by the presence of dust particles floating above the rings. Saturn itself has enormous winds, blowing at more than 1,000 miles an hour, and it seems to have a unique heating system.
Inside of Saturn, helium was forming into raindrops and raining down toward the center of the planet, and it was the falling of the helium raindrops inside of Saturn which generated the heat which kept Saturn warm.
Saturn also has a huge moon, Titan, with a thick atmosphere and smog similar to that on Earth. Titan bears a resemblance to Neptune's Triton, but actually may have extraordinary oceans.
We now believe, based on calculations, that ethane, which is a light hydrocarbon, is actually present in the form of oceans on the surface of Titan, having been made in the atmosphere out of the methane.
The most recent stop on Voyager's grand tour was Uranus, a planet with a strong magnetic field uniquely tilted 60 degrees from the planet's axis, sort of like having Earth's magnetic north in the vicinity of Los Angeles. Like Neptune, Uranus is mostly gaseous, hydrogen, helium, and methane.
It has no solid surface to stand on. Certainly it's not a place where man could live easily. There's just no oxygen, no water really in those portions of the atmosphere, and no place to stand.
Uranus had 15 moons. One of them, Miranda, appears to have thawed and refrozen, something which astounded scientists. Another, Ariel, may have had glaciers, but not of ice as we know it.
Too cold for water ice to flow, so if it is a glacial type flow, it must be water that has mixtures of other types of materials in it to cause it to melt at a much lower temperature than water ice.
Uranus also has a series of rings, which may resemble the ring material around Neptune. Voyager left Uranus 3 years ago en route to Neptune, where now the spacecraft's grand tour is nearing an end.
And that's it for now from the Jet Propulsion Laboratory, where in about 3 hours we will know for sure just how Voyager's close encounter with Neptune went. Patrick and Donna?
All right, Dan, thanks so much. And we thank you for joining us for this special edition of Newsnight. And we'll have another update and more pictures for you in a little over half an hour on Newsnight Update. Thanks for joining us. I'm Donna Kelly.
I'm Patrick Emery. Have a good evening.